All right, so we're gonna go ahead and talk about number three now. So basically, what we got going on is a car is depreciating, right? And the starting value is 23,000. So that's my P value. It's always my start value. The interest rate is 8%. Now, please do be careful a little bit with this. 8% is you have to move the decimal over 2 spots, always, percent 2 spots. Please remember that. So this is 0.08, not 0.8. 0.8 is 80%. And the way we talked about this in class was depreciation happens once a year. Cars get older when they're a year older. It's really like a set moment of time. It's not continuous. So we have these two formulas we've been working with here. We're going to be using not PERT, but we're going to be using this guy right here because we know how many times it compounds. It's once. So our formula ends up looking like this: 23,000. 1 plus 0.08 divided by 1, because my n is 1. We're compounding one time a year. And then I don't know how long it's going to take to get 15,000. So we're now going to need our calculator for that. So why don't we see if we can figure this out. All right, so our formula was 23,000. So 1, 2, 3, parentheses. Now, I don't know if I did this right or not. Let's double check here. Oh, I wrote 1 plus, and that's definitely wrong because this is a decay. It's shrinking, so it should be 1 minus, right? All right, so now let's go back to our calculator, and we're going to do 1 minus, and I'm going to make it look like just, it's not a big deal in this case, but I'm going to do alpha y equals, I get a fraction, make it look like a fraction. I tend to screw up less if I do that. So 0.08 over 1. And then I press over. Now I'm like over here. So now I do another parentheses, and now I do an exponent. So that's right here to the power of. And now we said it's going to happen 1x. So that means basically I have to have a variable up here if I'm in a table, because that's going to tell me how long it's going to take. So now I'm going to go to my table. Table is in blue, so I hit my blue button first. And we get this guy. We wanted to know when this guy was going to equal 15,000, right? Well, looks like it's not that long. So it looks like it's going to hit the 15,000 somewhere between 5 and 6 years. So 15 is a little bit high. Here's a little bit low, closer to 5 years, but we'll say between 5 and 6. So now we have between 5 and 6 years. That's it. All right, so now let's go ahead, and this wants us to actually come up with a rule. So do you guys see that this is 0 right here? Well, that's my starting point. Now, if it was 1, that wouldn't be my starting point. I'd have to go back to 0. Or there's some other ways, but let's just say that for now. So we have 90 is my starting amount. So we're dealing with basically P times 1 plus rate R times N. So really we have the same thing going on here. So the big question really here is, what is my rate? Like what are we doing to get my rate? So well, to find that out, what did we multiply 90 by? We multiplied 90 by my rate to get my next number, right? 56.3. So how do I find my rate? Well, just like we do algebra, I need to get R by itself. So we divide by 90. And now I got 56.3. So I'm going to go back to my main page, and I got 56.3 divided by 90. And that gave me 0.625 roughly, 0.626 maybe. So my rate is 0.626. And so now we have this. We have my starting amount, and then we have times, so that's my starting amount, right? Times 0.626 to the power of x. And that is this formula right here. So if I plug in a 1, that will give me this. If I plug in a 2, that will give me this, and 3, and I can check my answer, right? Now, what if they didn't give me a 0? Could I still do this? The answer is yes. Another way of doing this would be, what if I gave you 56.3 as my starting rate? Well, my rate is still 0.626, right? That's still my decimal. And now the difference is, instead of starting at 0, we need to do this, x minus 1, because we're not starting at my 0th number, we're starting at my first number. We could start at 35.2 and do x minus 2, and so on and so on. All right, hope that helped.